Let's take a look at additional maths, chapter 5, part 2. So today we're looking at 5.3 and 5.4 and 5.5, right? 5.3 to 5.5. So the first part is sketching the graphs of cubic polynomials and the moduli. Their graph, how to sketch the graph. You know, cubic means we have 3 roots. Cubic means we have 3 roots. Quadratic means we have 2 roots. Cubic means 3 roots, meaning if this is the horizontal line, just a moment, okay. If there is a horizontal line here on the x-axis, which is the one you call x-axis, and this is y-axis, you can see this graph has touched this place 1, 2, 3. Okay, that means that you know the value of x are the roots of a quadratic or cubic equation. So it means there will be 3 x value. There will be 3 x value. So that's what cubic equation means. And it can be simplified in this format. It can be shown in this format as y. Can be shown in this format as y equal to kx minus a, x minus b, and x minus c. Can be simplified in this format. Now let's take a look at an example. Let's take a look at an example. Okay. Let's see this first question. You say, sketch the graph of the function y equal to x minus 1 multiplied by 2x plus 1 multiplied by x plus 3. And then here, sketch the graph of the modulus of it. You know, once you see a line like this, it means the modulus. Once the whole equation is put like this, it means the second phase of the question says you should sketch the modulus of the graph. Now to sketch that graph, the first thing we do, we go to, it's a cubic because you can see 3x, 1 here, 1 here, 1 here. So it's a cubic function. It's a cubic cubic equation. So we go to find the values of x and their corresponding value of y, meaning we're going to have 3 coordinate points. Like we can say, for example, point A where the graph touch x-axis, point B where the graph touch x-axis in the second place, and point C where the graph touch. Each of them will have the coordinate point, the x and y value. You know, every point you plot in a graph, you're going to have the x and the corresponding y value. Every point we plot, let's say for example, if you have this graph, if you plot this point, x is -3 and y is 0. You trace the y-axis is 0 and x is -3. If you touch this point, x is maybe like -0.5, which is half, and y is 0. This point is x is 1 and y is 0. So they are the coordinate point, okay, where this touch the x-axis, where the graph touch the x-axis. Now the first thing we do when we are describing this is that we say when x is 0, what will be the value of y? We substitute it to this equation that is given to us. If x is 0, if I put 0 here, let's say here is 0. This one you assume yourself, okay? You assume x is 0, y, here will be 0 minus 1. That's -1, right? We'll get -1 from here. You know, it's a multiplication. You get -1 here. You get -1 here. Then if you put 0 here, you get 1 here. If you put 0 here, you get 3 here. So you multiply all 3. -1 times 1, that's -1. Times 3, you get -3. So if x is 0, our y will be what? Y will be -3. Y will be -3. We only substituted 0 in the equation, okay? When x is 0, what will y be? Y will be -3. So we go to identify that coordinate. So we call the coordinate point for the first coordinate 0, -3. We call it 0, -3. 0, -3. S is 0. You go to your graph book. You go to identify that place. We go to identify it. When x is 0, this is when x is 0, right? You are going to draw this graph. This graph, assume it doesn't exist. You're going to sketch it. That's why they say sketch. When x is 0, y is -3. You put a point here where the y graph is going to pass through. There are points you're going to choose. X is 0, and x is, you're going to choose these ones from what is given to you in the equation. You're going to choose different value. X is 3 probably. X is like you are saying this. Let's assume y is 0. We're going to do that. You see now. When you say y is 0, you equate only this one to 0. You get x equals to -1, and x equal to 1, x equals to -half, x equal to half, and x equals to -3 if y is 0. We only assume x is 0 just now, and we identify the location. When x is 0, we put in our graph paper. Y is what? We put that sketch there, that point there, because we're going to sketch this graph. Assume this graph does not exist. X is 0, y is there, y is -3. So we put that point there on our graph paper. Now, have we obtained that? Then let's the curve we intersect at y equal to, okay, the curve we intersect at this point. We pass through where we just talked about. Now, when y is 0, we've obtained where the graph will pass when x is 0. When y is 0, what do you have? Now, let's take a look at it. When y is 0, you have x minus 1 in one bracket, right? We have x minus 1 in one bracket. X minus 1 in one bracket. And then 2x plus 1 in another bracket. 2x plus 1 in another bracket, right? 2x plus 1 in another bracket. 2x plus 1 in this bracket. And then the third one is x plus 3. X plus 3. This is the cubic function or the cubic graph that needs to be plotted or that should be sketched. In the exam, they ask you to sketch this graph. You say this is equal to y. It's supposed to be equal to y, right? However, we say y is 0 when you assume y is 0. Okay, when you want to sketch a graph, you first assume x is 0. You get the coordinate, the point on the y-axis, the coordinate point. And then you assume y is 0. When y is 0, what do you do? Remember how to do when this y is 0, when y is 0, you should equate only this first bracket to 0, only this second bracket to 0, only this third bracket to 0, right? So you can get 3 coordinate points here. Okay, now it means x minus 1 equal to 0. You take the first bracket. You take the first bracket, x minus 1 equal to 0. You're going to do them individually. Okay, x minus 1 equal to 0. You're also going to take this second one, 2x plus 1 equal to 0. You're also going to take x plus 3 equal to 0. You're going to do each of them individually. Okay, we can write the second one, 2x plus 1 equal to 0. 2x plus 1. 2x plus 1 equal to 0. Right? That's the second one. Then the third one is x plus 3 equal to 0. So we solve each of them. X plus 3 equal to 0. So that we get these 3 values for x. When you solve them individually, you get the 3 values for x. Right? We get the 3 values for x. Okay. Now, what this means is that I should move minus 1 to the right. So it means x equal to 1 for the first one. It means x equal to 1. Meaning on the graph, s is going to pass through 1. Okay, the curve will pass through 1. That means the coordinate, what will be the coordinate for this first one? It means x is 1, y is 0. Remember, y is 0 for all the 3 cases. Y is 0 for all the 3 cases. So if I ask you to write the coordinate will be 1, 0. This is the coordinate. Okay, we're going to locate it on our graph paper. 1, 0. Okay, this is the coordinate. We can call this one point A. We can call this coordinate point A, if you like. Okay, now let's deal with this. What is x here? First, you move positive 1 to this side, it becomes -1. So you divide both sides by 2. So I just go straight because you can do this, okay? X will be equal to -1 all over 2. Because first you move 1 to this side, it becomes -1. And then you divide 2x, you divide each side by 2. You get -half. Okay, so this is so the coordinate for this one will be this is the value for x, -half. So the coordinate will be -half or 0.5, -0.5. So you write either 1 over -1 over 2, or you write 0.5. It's up to you, it's the same thing. So -half, 0. That will be the coordinate. Why? Because we said the y is 0 for all 3 cases. We equate to 0. So the value of y will be 0. So this will be the coordinate of the second point on the x-axis. on the x-axis, where the curve will pass through. We call this point B, call this point B. And then the third case, just move 3 to the right. It becomes x equals to negative 3. X equal to negative 3. In the third case, x equal to negative 3. So when y is 0, you get 3 values for x because you equate everything to 0. You equate everything to 0, you get 3 values of for x. So, and once you get 3 values of s, you form 3 coordinates. For 3 coordinates. So what is this coordinate? Minus 3, comma 0. This will be this coordinate. Minus 3, comma. We can call it point C. Now remember we got the first point. Remember the first point on the y-axis we got when x was 0. We got when x was 0, we got 0 and negative 3, right? And we have identified that first point when x is 0. When s is 0, we identify this point. We identify this point. Now let's identify these 3 coordinate points, A, B, and C, on the x-axis. Now, negative 3, we start from the negative side. We start from point C, the one I call point C. Actually, it will actually be point A. We start from here. So, negative 3 and 0 is where? Here. Negative 3 and 0 is here. We plot the second one. Negative half and 0 is where? Here. Negative half for x and 0 for y is here. The third one, 1 and 0, 1 for x and 0 for y is here. So you can see your sketch now, right? We can see our sketch. We already have a point here, a point here, a point here, a point here. Remember you are drawing a cubic. So our graph is going to go like this. Now where we go to curve it, let's say minus 2, we have to find the y value at this point so that we know where the graph is going to turn. So we're going to substitute y equal to negative 2 into the function and see what we get for, x equal to negative 2 into the function, into this function. You put negative 2 here. And then you get what you get here. I think you're going to get 9. So that's where you go to curve. Now to know where to curve here, you know this one is coming down here. So here is 0.5, positive 0.5. You're going to substitute positive 0.5 in this function to know the value of, to know your value for y, where you go to curve, where your graph is going to curve. So you need to know, you are starting from here because you got it this coordinate point. So when I'm sketching, where will I turn? So I'm going to find the value of this one so I know where to turn since I'm turning here. So I'm going to find the value by substituting negative 2 for x in this function. So negative 2 minus 1, that's negative 3 in this bracket, times negative 2 times 2, that's negative 4, plus 1, that's negative 3. Negative 3 times negative 3, that's positive 9. Then substitute the negative 2 here. Negative 2 times negative 2 plus 1 plus 3, that's 1. 1 times 9, that's 9. So this coordinate point is negative 2. The turning point here is negative 2, 9. That's the coordinate point. So you have to get that point in order to be able to sketch the graph. We have to get the point. Okay, but although this of that, but I'm showing you, because the question will be, oh, how then do you know, assuming this is your graph, how then do you know where to turn, since we already identify here as negative 3 and 0, the first point here, we identify here negative half and 0. We identified when x is 0, the y was negative 3, right? We identify here as a point we're going to turn through. We also identify here 1 and, let's say here 1 and 0. These are the points we have identified so far. Now, we know our graph, because it's cubic, is going to go like this. We already know from what we've seen, right? It's going to go like this. Now, we're going to turn somewhere and pass through here down. We're going to pass through here down. We already know, okay? Don't mind my sketching, okay? And then we're going to come up here. We're going to come up here. If we like, we extend up, or we stop here. If we like, we extend up, okay? But the question, how do we turn here? Where do we turn? So the question is, you must know the x value here, which is negative 2, okay? -2, you substitute it to the equation and see what you get, 9. So meaning you go to raise this one to position 9, where you go to turn will be 9 on the y-axis. You see your sketch is done already. Because they will not say plot the graph. In ordinary maths, we say plot. In additional maths, we say sketch. So for sketch, you just go to obtain some certain points, and then you join the points together, and you get your sketch. Is that okay? Okay, so that's that for this. This is how we sketch the graph. Because this sub-chapter is sketching the graph. Then the second part of the question says we should sketch the modulus. A was to sketch this one. What do we do? In just a recap, we substitute s equal to 0, we get the value of y. So we write a coordinate of it. Now we substitute y equal to 0, we got the 3 values for x. And then we put those points on the graph. And then these 2 points where we need to turn, this point, we also substitute. So we are actually getting like 5 points. And this point. Once you get them, then you can put your graph, you can sketch your graph easily. Okay, the B part say to sketch the modulus. Anytime they say sketch a modulus, you reflect any part of the graph that is below the x-axis. Any part of the graph. Meaning anything below here have to be reflected, meaning it has to come up like this, has to come up. You see this line that is going down will be reflected to go up. You see this part that is below x, anything below x, nothing goes because there is no negative y for modulus function. So this one that is below, this curve is a curve. We're going to make it this way. This curve will be here, like this. So our graph will look like this. This one below will be erased. This one below will be erased, and this one will be erased. So the sketch of a modulus of the function will now be a graph like this, joining like this, joining like this, and like this, and like this, much as you want. This is the usual one where we curve at 9 down here. This part that is a reflection of what is here before, like reflection you did in transformation. The part that was below will be reflected to this way. Is that okay? It will be reflected this way, and that's it. That's your modulus graph. It's very easy. Once you plot the original graph, the modulus is very easy to sketch. The modulus graph is very easy to sketch. So that's for 5.3. Okay. Now let's take another example. Another example before we round up 5.3. Now it says sketch the graph below. The sketch graphs. Okay, the graphs were already sketched. The sketch graph below are examples of cubic functions of the form y equal to k into x minus a, x minus b, x minus c. Using the sketches, find the equation of the graph. Using the sketch, they say we should find the equation of this graph. Okay, so we're going to deal with them one after the other. We're going to solve this one for this sketch first before we come and solve this. There are 2 different graphs. There are 2 different graphs and there are 2 different figures. So you're going to solve them one by one. So we're going to take this one. Now, when you have a curve do not protrude down. It's only touch the y-axis and turn from that point, y-axis. It turns at this point. It turns here. You know, it's different from if it's like this. It's different from if you have this. If it's like this, it's different. You know, they are different. These are different. This one, you see there's a coordinate point here, one root at this point, and one root at this point. But for this one, when it turns exactly on the x-axis like this, you can see this situation. It's turning exactly, and also this situation. What it means is that there's a repeated root here. Meaning this number, whatever number is here, if it's 1, if it's 2, it's 3, whatever number at that point, that number is repeated. There are 2 roots of that number. Meaning x is 1 here, s equal to 1, and s equal to 1, twice. When there is a turning here, it means that. So, you know, every quadratic must have 3 answers for x. 1 is here at s equals to -2, and then 2 points here, s equal to 1 and s equal to 1. So these are the 3 roots. That's the first point I want to make. Okay. Now it says, let me zoom. Okay, let's zoom a little bit so you can see. Let's zoom a little bit So you can see. Okay, now it's a figure 1 is a cubic graph, right? You can see it's a cubic graph. Take a look at figure 1. It's a cubic graph. It's not quadratic. You can see 3 times. Touch here, touch up here, come down, touch here. And I say anytime this happens on the x-axis, it means 2 roots. Similarly, figure 2. Touch here and there, pass through this on the y-axis, and then touch here. Once there's a turning on the x-axis, that means there are 2 roots there. Okay, now we write the original form they gave us. You know, remember they say y equal to k to x minus a, x minus b, x minus c, where k is positive. Okay, k is positive. Now we go to start by say when our y is 0, we got to find the quadratic equation because we already know the roots. Why? We know the roots at s equal to what? S equals to -2. Remember here, s equals to -2. You know, x equals to -2 at this point is same as s equals to -2, right? Because this graph touches the x-axis at -2. It's same as say if you bring it to the right, it becomes what? S plus 2. Becomes what? X plus 2. Because I'm bringing this one to this way. S plus 2 equal to 0. So this becomes x plus 2. Okay, that's how this was formed. We're going to come here. I'm going to explain this. Because this A, B, and C are the values of x. The point where the graph touched the x-axis. They are the values, the point where the graph touched the x-axis. So this x plus 2 as a bracket that you're going to see later on is because s equals to -2 at this point. Here, s equal to 1 twice, meaning you're going to have it twice. S equal to 1. Twice you can, meaning you can write it 2 times. S equal to 1. So if you bring this one to this to meet x, it becomes x minus 1. Becomes x minus 1 equal to 0. So that's what we have, what we're going to have here. X minus 1 is twice. Because you're also going to bring this one to meet here, it becomes x minus 1. So now you have y equal to, remember how we did that? Because you say y equal to 0. You say y equal to 0. When you equate everything here 0, you say k into x minus a, x minus b, x minus c equal to 0. Then you can put the value of these ones where it touches the x-axis. Right? You put these values. And remember we say here s equals to -2. So when you bring it to meet s, it becomes x plus 2. Here s equals to 1 and s equal to 1 twice. You bring it, it becomes s equal to x minus 1 equal to 0, which is the value of y. S minus y equal to 0. Each of them equal to 0 because the value of y is 0. This one, x plus 2 equal to 0 because the value of y is 0. Because you have assumed y to be 0. That's why you're able to do this. You have assumed y to be 0. Okay? Meaning at this point, on this, you know this point, y is 0. On this horizontal x-axis, y is 0 at that point. That's what you are dealing with. You are dealing with the values of x when y, the vertical axis, is at 0 position. What are the values of x? Here and here. Here 2 numbers and here 1 number. That's what we are dealing with. Is that okay? So when y is 0, the x-axis is set at s equal to 1 and s equal to -2. S equal to 1 and s equal to -2 repeated root. So at s equal to 1 is a repeated root. So in order for us to find k, we have to do something. We have to substitute a value. We can choose anywhere in the graph. If you look at these two, this one is extended to where? It's extended to a singular point. It's extended to a singular point, this point. And the y value of that point is 8. So now we're going to substitute 2 for x and 8 for y. Like a coordinate point. 2 for x and 8 for y. See this point? We're going to choose a point. You can choose any point. It doesn't necessarily mean this one. You can choose any point, but make a point that's easier for you. If you choose like 1.5, you trace it here and trace it here and substitute. Here we are choosing 2 and 8. We're going to substitute in order to find k. We're going to substitute it to the equation. We're going to substitute. So you come, remember you already found this one. We've already got it, x minus 1, x minus 1, x plus 2. Using using these values, which we already got here, x plus 2 in one bracket, x minus 1 twice. We write this one twice, x minus 1 twice, okay? We substituted them for this a, x minus b, x minus c. A, b, and c are minus 1, and 2. So now it's only k that's remaining. So in order to find k, even if we equate this one to 0, it will not help us easily to find k. We have to find a value of x that is uniform and a value of y that signifies the corresponding value of y, which is this point we have chosen on the graph, which is this point we have chosen. A point where you can get one value for x and one value for y, right? Multiple values of x. We're using one-to-one mapping. We're going to look for where in the graph we can easily find one-to-one mapping, right? We can easily find one-to-one mapping. We choose that point and we substitute into this equation that we've already obtained. So in order for us to find k. So since y, we say x is 2 and y is what? S is 2 and y is 8. That's the coordinate point we chose. We're going to substitute that value. Okay, we're going to substitute these values into this function, So y is 8, you put 8 here, right? You put your k, you're looking for k. Then, remember x is 2, so you say 2 minus 1. This one is already there. Here also 2 minus 1. And here will be 2 plus 2, which is 4. So 2 minus 1 is 1. 2 minus 1 is 1. 2 plus 2 is 4. So it's like you say 4 times 1 times 1 times k. 4 times 1 is 4. 4 times 1 again is 4 times k is 4k. So 4k equal to 8. So at this point we have 4k equal to 8. 4k, right? Is it 4k equal to 8? Let's do it again. 2 minus 1 is 1, right? 2 minus 1 again is 1. 2 plus 2 is 4. So if we multiply 4 times 1, 4 times 1, 4 times k, 4k equal to 8. Then why are they getting 1 for k? K will be 2, right? We divide both sides by 2. I think the author made a mistake. This book has small mistakes. Okay, so if that is true, then we get our value of k. But they say k is 1, but k is 2 actually. So k will be 8 divided by 2 divided by 4, which is 2. So if k is 2, then our new equation will be x minus 1, x plus 2, and you put 2 outside here. You put 2 outside. Why they didn't put 2 here is because they said k was 1. So in this case, we found k to be 2. So if k is 2, you put 2 here. This is the equation. This is the equation of the cubic equation. This is the cubic equation. In summary, how did we get this cubic equation? In summary, we said we'll be given a function with k, x minus 1, x minus 2, x minus 3, and we'll be given the graph. So you look at the graph where it touches the x-axis, you get your 3 values, you substituted them here, right? And then you choose any coordinate point where you can have a value for x, a value for y. You substitute it to the function and find the value of k, and then you substitute the value of k back into the function. And then that will be the equation, the cubic equation they want you to find. You can leave it like this, x minus 1 in one bracket, x minus 1 in one bracket, or you just say, s minus 1 and multiply by s minus 1, it means s minus 1 squared. It means this one, instead of being repeated, you just square it, and then you say x times s plus 2. Okay, either like this or like this. And 2 is outside because our k was 2. Okay, k was not 1, except we made a mistake, but however, I think the author made a mistake. Okay, because if you substitute If you substitute 2 here, 2 minus 1 is 1, right? 2 minus 1 is 1. Even the author, you can see the author substituted. 2 minus 1 is 1. Multiply by 2, another 2 minus 1. We are multiplying, we are not adding. We are multiplying. 1 times 1 is 1. 2 plus 2 is 4. So 4 times 1, 4 times 1, 4 times k, 4k. 4k, we have repeated root, right? So it means we have x equal to 1, which is s minus 1 twice. S minus 1 and s minus 1 into a bracket, and x equal to negative 2, which is s plus 2, right? So in this case, we can say that k will be negative. This graph, k will be negative. This first one, k was positive. You can see this cubic graph, k is positive. It's a positive cubic graph. But this one that goes negative first, k is negative. K is negative in the second graph. So in figure 2, k will be negative. So we do the same thing. We say when y is 0, we substitute our values of x. What are our values of x? We had just now. It becomes x minus 1 as one bracket. And remember, it's repeated twice. Since it's repeated twice, we're going to have it again, x minus 1 again. So it's a repeated root. So we're going to have x minus 1 again. And then the other one will be what? Here, s equals to negative 2. When you bring negative 2 to meet x, it becomes x plus 2. So here we have the third scenario, x plus 2. We have x plus 2, right? And remember, there's k equal to y. Equal to y. Now, when y is 0, this is the equation that you first obtain from the graph itself. Once you obtain this by yourself, you say, now, your y is 0. If y is 0, we say when y is 0, that's when we get all of this. Because when y is 0, you know, x is equal to negative 2. Then that's when you bring negative 2 to meet x when y is 0. Here, x equal to 1. So because y is 0, you bring x to meet, and you bring 1 to meet x, it becomes x minus 1. Okay, the next phase is to find k. To find k, we're going to choose one point and we substitute a coordinate point for x and y. We're going to choose it and we substitute. In this case, because k is a negative value, we look at the x-axis. We say the x-axis intercept at x. Okay, that's for the. There is a repeated root. We found that already. Now to find k, substitute s equal to negative 1 and y equals to negative 4. Go to the graph. S equals to negative 1. You see this point? And trace it down to see the value of y. What will be the value of y? If you trace it here, y will be negative 4. You must always substitute one coordinate point. Okay? One coordinate point. Because k is going to be negative, that's why we choose that. If k was going to be positive, we would have chosen. There's not even any positive side you would have chosen here. Okay? Except maybe you wanted to consider here. Because k is negative, we choose this one. Okay? We choose this point, we raise it down, and we bring the coordinate point. We substitute it to this equation. We substitute it to the equation. Right? We put the value of k, the value of y, which is negative 4, here. And we substitute the value of s, which is negative 1, here, into this one. We substitute the value of y, which is negative 1, into this equation we've got. So that's what we do. We substitute k as negative 4. Where's negative 4? Here. Where's negative 4? Here, this place. You know this is the coordinate point we've chosen. We've chosen this point. So the value of k, the value of y is what? Negative 4. The value of x is what? Negative 1. So we are substituting negative 1 for x and negative 4 for y. So we substitute them into this our equation, we've already obtained. So y is negative 4. You put negative 4 there, and you put negative 1 in place of this place of x. Everywhere you see it. So negative 1 minus 1, you're going to get negative 2, right? Negative 1 minus 1, you're going to get negative 2, right? Negative 1 plus 2, you're going to get 1. So negative 2 times negative 2, 4. 4 times 1, 4. So this one is 4k equals to negative 4. Okay? Because you are multiplying the bracket. This is negative 2. Here you get negative 2. This first bracket, you obtain negative 2 in this first bracket. Okay, in the second bracket, we also obtain -2. In the second bracket, we also obtain -2, right? In the third bracket, we get +1. We get 1. We get 1. So you multiply all of them times k. All of them times k. All this one times k. So you get 4k equals to -4. So you get 4k equal to -4. So k will be equal to what? -1. Because you divide both sides by 4. K will be equal to -1. So that's how we got this k to be. Once you get your k, you substitute it back here to the original equation. So that would be your equation they want you to find. You say -1. You know in maths, you don't need to write -1. Just a minus. But whether you write it, doesn't matter. -1 into x minus. So you just say minus x minus 1, x minus 1, x plus 2. So this is or since this is a repeated root, you just say x minus 1 square into x plus 2. This will be your equation. This will be your equation of the graph. This will be your equation. Okay, so if you are given a graph, the point is summary. If you are given a graph, you are asked to find the cubic equation. This is what we do. This is how we find the cubic equation when you give you a graph. Is that okay? Okay, remember the first example was for us to sketch the graph. The first example was for us to sketch the graph, and the second example was for us to sketch the graph, and the second example was for us to the graph was given to us, and we've been asked to get the equation. Is that okay? Okay. So let's see what we have next. We finished this section. Okay, we have another question to look at. Okay, we're still in 5.3. Okay, we have one more question to look at. Now let's take a look at this one. Okay, I think we should be fast now. Sketch the graph of the function y equal to, anytime they say sketch, you go to say assume y equal to 0. If y is 0, then you go to equate this x to 0. And this is a repeated root. S minus 2 equal to 0 if y is 0. You equate only this x to 0. If you assume y to be 0, that's y equal to 0. And you say x minus 2 equal to 0. And x minus 2 equal to 0 will mean s equal to 2 twice because it's squared. Means you are going to have plus 2 twice. So, meaning the graph will pass +2, okay, on the horizontal axis. It's going to pass +2 on that point, straight on that point. Okay, assuming here is 2. The graph is going to pass through this point. And then, at 0 also, it will pass through 0. Maybe here is 0. Here's 0. Okay, if you sketch this one, because if y is 0. And then you also go to say x, when x is 0, what do you get for y? When x is 0, you substitute 0 here. 0 minus 2, that's -2. You go to find the value of y. You can expand this one out, write this one twice, so that you not be confused with this square. Okay, now let's begin. We say when x is 0, y is when x is 0, y will be what? 0 times -2 squared. It means y will be 0 when s is 0. So y will be 0, meaning here will be this point. There will be this point to pass through this point. S is 0, y is 0, this point. Okay. So that's the first thing you do. You get that first coordinate, and you get the point on your graph. And then when y is 0, which I already explained, when y is 0, you go to, if y is equal to 0, you go to say this x will be equal to the 0. You equate this one to 0, then you x equal to 2 and s equal to 2 also. So you have 3 points. You have 0, s is 0, s is 2, and s is 2 3 times. So you can write all the 3 coordinates 0, 0, 2, 0. Okay. Then here we say as x approaches infinity, y will also approach infinity, positive infinity, and as x approaches negative infinity, y also approaches negative infinity. What that means is that as s increases, y will increase, as x decreases, y will decrease. Okay, we use these values in additional mass. Okay, now the graph will be sketched because we've already obtained all the points. You have 0, 0 when s is 0, y is 0, and you have repeated root at 2. So you go to have here. Now to know where you curve, you can trace this one down to x, maybe 0.5. You substitute 0.5 into this function, When s is 0.5, what do you get for y? When s is 0.5, you substitute here. You know the value of y, that's where you go to curve. Maybe you get 1. That's where you go to curve, okay? And then that's it. You sketch your graph. Easy, right? If they want the modulus of this graph, what do? Only this one that is going on the negative side of the y-axis, you go to draw upward like this. Only this one you go to draw upward. Finish. You cut this one out. Everyone that is up on the positive y-axis will remain like that. Only this one that is going down the negative y-axis, you cut upward. That's the modulus graph. Is that okay? See, look at it. It's sketched here. This is the modulus. The one that is going down this way will be brought up this way. That's it for this question. Okay, so that's all for here. You pause this video and solve these questions. The more you do, the better you become, okay? They are not hard, but you have to practice. You have to practice. You have to practice, okay? And pause this video, solve these questions. They are not hard, trust me, they are not at all. Just follow the pattern we've described, and so on and so forth. Now let's go to 5.4. Let's go to 5.4. Okay, it's lagging a little bit, okay. Let's go to 5.4. 5.4 is solving cubic inequality graphically. Solving cubic inequality graphically. It said the diagram shows part of the graph of y equal to half into s plus 3, s minus 1, and s plus 1. Use the graph to solve this inequality. Use the graph to solve this inequality. Meaning the graph is given to us. That's why they say use the graph. They are not asking you to sketch the graph. The graph has to be given. They say use the graph to solve this inequality. So this whole graph is drawn already. Okay? So first and foremost, let's write what they ask us to solve. You write this one down. You say x plus 3 in one bracket, s minus 1 in another, s plus 1 in one bracket is greater than 2. Now, how does it become this? What should we do for this one to become equivalent to this one? Okay? Because this is a part of the graph. So to do that is to divide both sides by 2. Because if I divide here by 2, this one will be 1 all over 2. If I divide here by 2, the whole of the left, this whole left. If I divide it by 2, it becomes 1 all over 2. You know, instead of saying divide by 2, you can say multiply by half. So multiply here by half. If I multiply here by half, it will be 1. Like 2 times half will be 1. And this will be 1 over 2, you see. Now when you have this, when you divide both sides of the equation by 2, you have this one that is part of the graph. Okay? The next thing you need to find where the curve, this curve, is above the line y equal to 1. Where is above the line y equal to 1? Because you are saying this whole thing is equal to 1 now. It's greater than 1. It's greater than 1. Where is this inequality greater than 1? Where? This part with red, this part. And this one. The whole of the inequality, this graph, where is it greater than 1? According to this equation, where is it greater? Is it greater than or equal to 1? Where? Only this part of the graph is greater than or equal to 1. Only this one and this one. Every other green one down is below. Is below 1, right? So on the y-axis, you know, this is y value. This one is y value. On the y value, where is greater than 1 is this red part. So we write the inequality for it, meaning you trace this one to this place, and you trace this one to this place. Finish. That's your solution for the graph. Where this is greater than 1. So you write the inequality. What will be the inequality? You can say x is you write the bigger one. X is lesser than negative 1.5. This place is negative 1.5. You can see it's halfway. Negative, let's assume it's halfway between. Yeah, because here is negative 1. Here is negative 1.5. Here is 2. Okay, there is halfway negative 1.5 and negative 2.7. This one is the negative 2.7. Because we are looking for where is greater than, which value of x, where the graph will be greater than 1, where y will be greater than 1. Okay, we are looking for which part we've demonstrated with the red one. Okay, so you write the inequality for this. Also, we're going to write the inequality for this. So you trace this one down also. 5.5, which is the last part of this class. Solving more complex quadratic equation. Okay, here you're going to need a small knowledge of your indices. The indices knowledge you have before. You're going to have it here. Okay, remember when we write, you'll be wondering, x to the power of 4, is it quadratic equation? What, we have cubic power 3, quadratic power 2. Is it quadrilateral equation? This power 4. So how do we solve power 4? All you have learned before is power 2. Probably just now you learned power 3. Now, how do we solve power 4? But no problem. We can make assumption. X power 4 can be same as power 2 times power 2. X to power 2 multiplied by x to power 2, right? Multiplied by x to power 2. Power 4 is like x power 2 times x power 2, right? Now, we're going to make one assumption. Let's assume that s to the power of 2 equal to y. In maths, we make assumptions. You say, let y equal to x to the power of 2. This one. In mini, s power 4 will now be what? Y squared. Am I right? It's like you're saying y times y, which is y squared. It's like you're saying y times y, which is what? Y squared. Which is what? Y squared. So x power 4 is what? Y squared. S power 4 will be y squared. Y squared. This is equal to s to the power of 4. X to the power of 4. Because we make s to the power of 2 to be equivalent to y. So that's what we're going to do. If they give you this, we're just going to use what they call the substitution method to solve. And then we solve the quadratic. So we say use substitution method and let y equal to what? X squared. Once you do that, y squared, then remember this is negative 3. This is negative 3, s squared. Now this s squared is y. Remember, this will now become what? Minus 3y. We are only substituting, anywhere we see s squared, we are only replacing it with what? Y. That's what we did. That's what we just did. This one now will now be minus 3y. And then minus 4. You see, it has reduced to normal quadratic. That big problem, by using substitution method, we've reduced it to normal quadratic. So we're going to solve this quadratic. You look for two factors. If you multiply them, you get negative 4. If you add them, you get negative 3. That's 4 and 1. Negative 4 and 1, right? Negative 4 and plus 1. Negative 4 times 1, you get negative 4. Negative 4 plus 1, you get negative 3. So meaning in one bracket, you say y plus 1 in one bracket and y minus 4 in the other bracket equal to 0. And then y equal to, here, y will be equal to negative 1. And here, y will be equal to positive 4. Y will be equal to positive 4. But that's not the end. Remember, it's you only make assumption. You come back to your assumption. Remember, you say y was what? S squared. That's the assumption you made at the beginning. So you're now going to follow it through. You're going to fulfill your promise. Since y is equal to 1, you will now say this y is now equal to 1. You say s squared equal to negative 1. Y squared, y equal to negative 1, therefore means s squared equals to negative 1, right? Because you say y equals to s squared. So you replace y with this value, s squared equals to negative 1, right? And there's no root. Because if you find square root of negative 1, it will go to a complex number. Okay, that's a different chapter we're going to learn later on. If you find square root of this and square root of this, this one will be, there's no real solution for this type of problem. But we look at this one, you find the square root of this, you're going to get plus minus 2. You're going to get what? Plus minus 2. Why? Because minus 2 squared will give you 4. minus plus 2 square will give you 4. Okay, so that's the solution. And this is the method we use to solve this easy method. The other method is a bit complicated, so no need to waste our time doing that, because that one means that you got to break this one down with each factor. It's a bit complicated. So, but the easy method we've explained. Now, let's use the same method we've talked about to solve the one that have the same problem. Like you say, use the substitution method of y. So, meaning anywhere you see x to the power of 1 all over 3, you put y there. To solve this equation, x to the power of 2 over 3 minus 1 minus x to the power of 1 over 3 minus. Okay, x to the power of 1 over 3 is already y. Remember, this one means what? 2 over 3 means, let's put it like this. 2 over 3 means s raised to the power 1 over 3 times 2. 1 over 3 times 2. 2 over 3 means I take the 2 separate out, so that this one can become y times 2. 2 over, because 2 times 1 is 2, and it becomes 2 over 3 again. So it's like I just break this one out. So I can have my, because they say y is what? 1 over 3. So I can call this one y. I can call this one y. And if I call this one y, it will become y squared. It will become what? Y squared. So I replace here, meaning here I have y squared. Instead of this, s to the power of 2 over 3, I have what? Y squared. And this one is what? Y. Because they say y equals to x to the power of 1 over 3. So this one is y. And then you say minus 6 equal to 0. You see? Normal quadratic. So you just use your normal factorization in the ordinary mathematics to simplify this. What are the two factors if you multiply? If factorization method can solve this, if you multiply them, you get negative 6. If you add them, you get what? You get negative 1. So what are those factors? 2 and 3. Right? To get negative 1, then it means the negative will be the bigger number, will be minus 3. So minus 3 and plus 2. So you write y minus 3 in one bracket, y plus 2 in the other bracket equal to 0. Y equals to, you move this one to the right, y equals to 3. And this one, y equals to negative 2. Remember, that's not the end. When you get your value, your two values of y, you have to go and get your x. You have to go and get your x. You have to get your x values. Now, remember the assumption you made. You say x to the power of 3 equal to y. Now, we found y to be 3. So it means x to the power of 1 over 3, sorry, not to the power of 3. X to the power of 1 over 3 is equal to what? 3. Because you say y is 3. You just solve y to be 3. It's equal to 3. Now you're going to remove, I'm going to cube here, meaning I multiply here by 3. I also multiply here by 3. If you cube here, why am I multiplying here by 3? Because if you multiply here by 3, this 3 numerator will cancel this. You have only x left here. Indices, normal indices. And then you multiply here by 3, it will be 3 to the power of 3. So s equal to 27. S equal to 27. So we got this value of x equal to 27. So we also equate this one. We say s to the power of 1 over 3 equals to negative 2. You did the same thing. You multiply here by 3, power 3. You also multiply here power 3. Okay? You cube both sides. That's the language. Cube here, many times power 3. Also here, cube here, raised to power 3. If you cube here will remain only x, because 3 will cancel 3. 3 in the numerator, which is your cube, we cancel the 3 in the denominator. You have only x left. And then this one, negative 2 raised to power 3, you get negative 8. So these are your solution. Okay, these are your solution for this type of equation. These are your solution. So I think one more example, we are done for today's class. Okay, this example. Same here, they say solve this equation. So when they give you weird equation, they say solve, your mind should go to substitution method. See, they say we should solve this equation. Okay, we have two more examples left. They say we should solve this equation. X plus root x equals to 20. So what you should just do, assume root x equal to y. If root x equal to y, if I square here, square will cancel square root, and I square here will be y squared. I don't know if you're getting the logic. So assume y equal to square root of x. So if I square here, and I square here, this square will cancel this square root. It means ordinary x will remain here. It means ordinary x equals to y squared. Ordinary x, that's why this one became y squared. That's how this one became what? y squared. Logic. You have to, mathematics make you think faster and better. So you get y squared plus y, because you have assumed this one to be y, root x to be y. So this will be y minus 20 equal to 0. So you solve this quadratic. Solve this quadratic easily. What are the two factors? If you multiply, you get negative 20. If you add them, you get plus 1, 4 and 5. Okay? Minus 4 and 5, because you're going to get positive 1. So you just say y minus 4. You always break it down, okay? Break it down. You know, it's easy to know. So y minus 4 in one bracket, y plus 5 in one bracket equals to 0. You bring this one here, y equals to positive 4. This one, y will be equals to negative 5. So remember the assumption you made. Remember you say y equals to root x. So root s equals to the value of y you found. You say equal to 4. So you square here to remove the root. You square here. If you square here, square will cancel square root. If you square here, s will be equal to 16. Square both sides. In this case, you square both sides. Now for this one, y equals to negative 5. Root s equals to negative 5. If you square both sides, you're going to get y, you're going to get x, square will cancel, s will be equal to negative 25. This one has no real root solution. Okay, this one, second one has no real root solution. Okay, so we're done with that. Now we go to the last, but not the least, for today's class. Solve the equation 9 raised to power x minus 10 into 3x, 3 raised to power x plus 9 equal to 0. For sure, if you really understand what we'll be doing, you should know this. This one will represent y. So you say, because this is simpler than this, you cannot use the one to represent y. So you say, because this one simply, 9 means 3 square. It means 3 square multiplied by x. 3 square x. Which we can rearrange to be 3 to the power of x, so that you look like this one. Then square times 2 times 2. The times, we can use bracket to show the times. Okay, this one is what I'm breaking. So which means if this one is y, the whole of the first one will be y squared. It's just a play on some numbers. This one will be y squared, and this one will be y. So the equation will become what? See how we break it down? 3. You'll be wondering how this one became 3 to the power s then squared. It is because you first break it down. 9 is 3 to the power 2, then multiply by x. You can bring the s first and then 2 out. It's the same thing. You just calculate. This one become what? This one become y. 3 to the power of x become y, and then it becomes y squared. So you look for two numbers. If you multiply, you get positive 9. You solve for this quadratic. If you multiply the two numbers, you get 9. Right? If you add, you get negative 10. So it's going to be 9 and 1. Yeah. Both of them will be minus 9 plus minus 1 will be negative 10. So these are your two values. So you're going to write y minus 1 in one bracket and y minus 9 in the other bracket equal to 0. In most cases, they will give you the one that you can easily factorize, not the equation that will lead you to a quadratic formula. But if the equation leads you to a quadratic formula, no problem. You already know how to use quadratic formula to solve quadratic equation. So you simply say y minus 1 in one bracket, y minus 9 in the other bracket equal to 0. So you equate this one to, you bring each one to 0. Y minus 1 equal to 0, then y equal to 1. Y minus 9 equal to 0, y equal to 9. So you get this. Remember, when you get your y, that's not the end. You go to complete your assumption that you made. Remember, you made the assumption when you were starting, and the assumption was that 3 to the power of x equal to y. So in place of y, now you put 1. 3 to the power of x equal to 1. What this one means is that you'll be wondering, why is this one 0? How this one jumped to 0? Indices, you forgot? Now let me show you. And 3 to the power of x, 3 to the power of x, 1 means what? In indices, 1 means if you want the same base, it means 3 to the power of what? 0. You know, in indices, 3 to the power of 0 equal to 1. So this one will be replaced with 3 to the power of 0. So since the s will be equal to 0. So that's how we use indices to solve this one. That's how we use indices to solve this one, and we got 0 here. 3 to the power of 2. 9 is 3 to the power of 2. So for the second one, you say 3 to the power of x, 3 to the power of x is equal to what? 9 means you have to break 9 down. 9 is 3 to the power of 2. 3 to the power of 2. So since the bases are same, you equate the power. You equate the power. So our power s equal to 2. That's the power. That's how we got 2 here. Okay, so you bring quadratic. You see how much is intertwined? You bring quadratic, you bring indices, you bring so many things, substitution method, factorization, so many knowledge in mathematics you bring in solving questions. Okay, so you pause the video at this junction, you solve all these questions. They're easy. They're easy. S squared, like this one, s squared equal to y. Here will be y squared. 12y squared plus 10y minus 2 equal to 0. You solve. So they're easy. Just this one, it means x raised to power 1 over 3 equal to y. This one will be y squared. Y squared minus y minus 6. I think we solve exactly this question. Minus 6 equal to 0. Then you solve this one. So they're easy. This one is y. It means 21 over y plus 80 over y squared equal to 9. Then you solve. Okay? So you pause the video, solve all these questions, and we will say, if you true to it, this one will be y, this one will be 2y squared, this one will be 2y squared. Okay? So this one will be y, and so on and so forth. This one will be y, this one will be y squared. Pause the video. This one will be y, this one will be y squared. Pause the video, solve this question as many as you can. This one will be y, this one will be y squared. Pause this video and solve all of this. With this, we come to the end of our today's class. Thank you for joining us. Okay? Thank you.